Hello students, welcome to this new lecture. Myself Chandrakant Behra, and in this lecture we will discuss about relation and function. So students, what is relation? Have a look here. A collection of order pair containing one object from each set. So students, here we have two sets A and B having element X and Y respectively. Then the element from set A is X and the element from set B is Y will be the pair, and this pair is the subset of the Cartesian product of two set A and B. Right, here is an example. As you can see here, A having 4 number of element and B having 4 number of element here as well. Then this is the relation from element A to B, and these are some pair as you can see here. Okay, so now students, look here the function. What is function? Let me first tell you what is function. Function is nothing but it's an operation which accepts inputs from the domain, and under the operation it shows its result in the codomain. That means, for example, mathematically we can write if f such that x from y, a function from x to y, then this is the domain part, this is the codomain part, and this is the operation. As you can see here students, fx is equal to x square is an operation, and for example an element, for example here is set A and here is B, so the element from set A 3. Okay, so here is let us consider here is 3, and under the operation fx is equal to x square, so the image will be 9, right? So 3 here is x square and 3 square is equals to 9. Here is another 5 under the operation, that is 5 square we have 25. Here is minus 5, and under the same operation we will get 25 as well. Okay, so this is the function. So it tells us it accept input from the domain part, right, and give its output in the codomain part. Students, have a look what is domain and range. As you can see here in this function from x to y, we have 1 2 3 in x, a b c d in y, right? So there is a mapping from x to y, as you can see here. Here the domain is, this part is the domain part, that means all the elements of x will be the domain. Okay, and all the element of y will be the codomain, right? The codomain is considering all the member in set y will be the codomain. That means the codomain is a b c d, and the domain is 1 2 3, and the range will be the image part, all the image part from the set x, that is 1 have a, 2 have b, 3 have c. So that will be the range of the given function. Okay, so this is the basic things about domain and range. Students, here have a look what is equivalence relation. So this is a symbol of equivalency. A relation R on set A is said to be an equivalence relation if and only if the relation R is reflexive, symmetric and transitive. Okay, so students, here I have taken an example here, a set A having 3 members A, B, C respectively. So with the help of these 3 members, by using this table I got some pair here. As you can see here, there are 9 pair. Okay, so I have taken some pair here to show that the relation is an equivalence relation. So here first we have reflexive. So first you need to know that the condition should satisfy for reflexive, symmetric and transitive. Okay, here I have A belongs to R for every A belongs to A. In symmetric, if AB belongs to R, then the symmetric is saying about that BA will be belongs to R for all AB belongs to A. And the transitive, if AB belongs to R and BC, C is another element, if BC belongs to R, then that implies AC is belongs to R. Okay, so for all A, B, C belongs to A. So if three condition, the above three conditions satisfied, then we say that the relation is an equivalence relation. Students, here I have differentiated this function in four different mainstream categories. As you can see here in your screen, we have one, many one, onto, into. So onto, into function is applicable in both the cases. So let's have a look what is one function first. So one function says each element of the domain part will have one images in the codomain part. That means, for example, here is one element will have one images, one element will have one images. That means for 1 we have A, for 2 we have B, for 3 we have C. So that is called one function. Okay, so here we have onto function, into function. For one function, then we will get onto and into both the function. So what is onto function? Let's see. Onto function is when codomain is equal to range, so that means that is called onto function. For example, here we have three elements, as you can see here, 1, 2, 3, and here we have the range is same. So that means one element will have one images, as you can see here, and the codomain is having three elements and the range will be also 3. So that means codomain is equals to range here. So this is called onto function. And when it is into function, when codomain is greater than range. So as you can see here is in the codomain part we have 4 elements, and in the domain part A we have 3 elements. So that means the range is here 3, that means here 1, 2, 3, and there is one element which one is not an image of any member of the set A. So that is called the into function. Okay, here we have codomain, that means codomain will have 4 elements and range having 3 elements. So this is clearly said that this function is into function. And the same thing also applicable in many one cases. Here as we can say a set A having 3 elements and a set having 2 elements. So when it will be many one, so that means many element will have one images. So that is called many one condition. So here 1, 2 will have one images, that is A, and 3 have one images, that is called B. Okay, so when it is onto and into, the same thing here we have onto function, like here 2 element have one images, one element have one images. So here the codomain having 2 elements and the range is also 2 elements. That means here we have codomain is equals to range. So this is called many one onto function. And into function, when it is into function, same thing also repeated here. We have 3 elements in set A and we have 3 elements in set B, but in many one condition we have one element one images, and here 2 element will have one images, and here is one element and which is left, which is not an image of any member of A. So this is an into function, because here we have codomain. Codomain, there is 3 element in the codomain and the range is equals to 2. Okay, so we clearly said that the codomain is greater than range. So this is into function, and totally we can say this is many one into function. Okay, so students, thank you so much. So in this next lecture we will discuss some more numericals related to one onto and many one onto into.